All right, so page 167, 1 through 45, every other odd. Not a bad idea to list them out first. That way, well, I guess you could still make the same mistake. Students, if they miss one of the every others, then they miss the rest of them because they're off by one the rest of the way. That's kind of frustrating. Although it doesn't bother me because you've still done plenty of calculus practice. Let's look at 25 and 29 and 37. So 25. Where it's asking for absolute extrema. Excuse me. Absolute extrema on that interval. So absolute extrema means I need to check the relative extrema and the endpoints. I'm going to write way more than you probably need to do. So absolute extrema means check the relative extrema and the endpoints. So checking endpoints is one thing that people forget to do. Relative extrema come from our critical points. So endpoints they give to us, critical points are where f prime equals 0 or f prime is undefined. So we got to do all this work to sort of build up to, our goal is to find the absolute extrema, but it takes a little while to get there. So endpoints we have, they gave those to us. Now let's find our critical points. And we need to do a derivative. So quotient rule. That's why I picked this one, just to see the quotient rule again. F prime is 2t. G prime is 2t. Okay, so this might be interesting, whatever happens here. So quotient rule is gf prime minus fg prime. So gf prime minus fg prime all over g squared. Looks like a bit of a mess, but 2t cubed and 2t cubed will cancel out in the top, and I'll be left with just 6t. Constantly going back and forth between calculus and algebra here. Are we okay with this as our derivative? You okay with distributing and canceling all in one step? So g prime equals 0, that would be where 6t equals 0. So that would be t equals 0. So that's one of our critical points. G prime undefined would be where the bottom is equal to 0. And you've got some options here. You could try to work this out, or you could look at it and say, well, look, if I square something and then add 3 and then square that, I'm going to get a positive number. Like there's no other way around that. So there aren't any places where g is undefined. If you want to sort of work it out the long way, square root both sides, move the 3 over, and then you're trying to take the square root of a negative number, and that doesn't work. At least it gives you imaginaries. So there's no places where g is undefined. This happens a lot, and so a lot of times students forget to check for it. And hey, half the time, if you forget to check, you'd be fine. But we'll throw some on there where if you don't check them, you'll miss it. So t equals 0 is my only critical number. So back up, kind of big picture here, literally zoom out. So my critical points, I found that was t equals 0. So I'll check t equals 0 and the endpoints to figure out the absolute extreme. So table of value, -1, 0, and 1. And so g of t was kind of a weird function, but if I'm only having to check zeros and ones, surely it's not too bad. If I plug in -1, I get 1/4. If I plug in 0, I get 0. And if I plug in 1, I also get 1/4. So we have an absolute minimum at 0, 0. And we have an absolute maximum. Oh, we have a tie. And that's okay, we just have to list them both. At -1, 1/4. And 1, 1/4. So the minimum happened at a critical point. The maximum happened at both of the endpoints. Check the endpoints, check the endpoints, check the endpoints. All right, let's look at number 29. So same section. Find the max and min. Find the absolute extrema. Or y equals 3 minus t minus 3 on -1 to 5. So big picture, it's the same type of question going on here. Is I need to check the endpoints, I need to check the relative extrema, but I only find those from the critical numbers. The critical numbers come from the derivative, except that we have not taken the derivative of an absolute value. But we're taking a derivative in order to find where is the derivative equal to 0, or where is it undefined. Okay, well, let's think concept here more than process. What's like the key signature thing that goes on with the absolute value graph? What's the graph look like? Yeah, there you go. See some of these. Yes, the V. What do we know? Like, this isn't this graph because it's minus and it's shifted around and who knows, but somewhere this thing has a V in it. Well, what's going on at the V? What's our calculus fancy word for that? A cusp. And what's happening at a cusp? Or why do we care about cusp? You can't take a derivative there. So at the cusp, we're undefined. So let's not take a derivative because we don't know how to take a derivative of that. Let's instead just know that at the cusp is the only place it's undefined. And it's not 0 anywhere, right? Regardless of what this thing looks like, how maybe it's steep, maybe it's shallow, maybe it's upside down, but whatever, the only problem is at the cusp. So it's not going to be 0 anywhere. It's just that cusp that's going to be the problem. Now, can you look at this and tell me what value of t the cusp occurs at? It doesn't matter what's out there, it only matters what's in here. The cusp always occurs where the absolute value is 0, because that's where it's going to make the turn. So there's a cusp at t equals 3. And so t equals 3 is a critical number. And so 29 is tricky because you don't actually take a derivative. You really just know that a cusp means you can't take a derivative, and so that gets you your critical point. So you got your critical point without having to take a derivative. Now it's just a table of value with the endpoints and the critical point and seeing who's max and who's min. So if I plug in -1, 3 minus absolute value of -4, 3 minus 4 would be -1. If we plug in 3, we get 3 minus 0. That was why it was the critical point. It was the place where it turned around. If we plug in 5, 3 minus 2 is 1. And so now we're just looking, without graphing it, and without graphing everything, the lowest point is -1. So there's an absolute min at -1, -1, and an absolute max at 3, 3. And I think if we'd have paid a little more attention to this graph, that would make sense, because the absolute value part was negative, so it's an upside down V. And so that means our max occurs where the V is. And the min occurs at just whichever endpoint goes lower. So I definitely wanted to see an absolute value one, because that throws people off. They start thinking process, how do I take a derivative? Instead of thinking concept, where is that derivative undefined? Well, at the cusp. I don't need to use calculus to know where the cusp is. That's an algebra thing. So calculus concept, but I didn't actually have to take a derivative. All right, number 33? No, 37. Yeah, 33 is just pretty straightforward trig stuff. 37, f of x equals 2x minus 3. Find the absolute extrema of the function, if any exist. That seems like an important parenthetical comment there. If any exist on each interval. So 37 is really 4 problems in one, but 2x minus 3, I can handle that. So 0 to 2. So 2x minus 3, that would be begin at -3, and closed circle because we want to include the x equals 0 point. Slope is 2, so up 2 over 1, up 2 over 1. Up 2 over 1. Oops, I wanted to stop at 2, so we'll stop it at x equals 2. That's a straight line there, believe me. So the big deal is closed circle, closed circle. So there's a max at 2, 1. There's a minimum at 0, -3. It's like, what is the point of that problem? That was like an Algebra 1 student could hopefully answer that question correctly. Part B, though, we want to look from 0 to 2, but 2, we don't want to include 2. So at 2, we've got an open circle. I guess if I was doing this in pencil, I could tweak my graph easily. So closed circle at 0. At 2, 1, it's an open circle. So max, min, Except, what's the problem here? There is no max, because I don't ever get to 2, 1. There is no maximum. Okay, and again, that's a little bit tricky to some people, because they're thinking maximum, well, it never gets above 1. And that's a true statement, but it also never gets to 1. So there's no number you could assign as the maximum value, right? It gets to 0.9, but it gets higher than that. It gets to 0.99, but it gets higher than that. It gets to 0.99999999999, but it gets higher than that. And so there's no way to say what the absolute max is. Absolute min's at 0, -3. So I'm not going to do C and D. The big thing for that is if you got an open circle at one end, you better be careful because you may not be able to get to the max or the min. And again, I say you may not be able to get to because if this was our graph, does that graph have a max? Yep. Does it have a min? Yep. So just because the open circles doesn't mean it doesn't have one. It just means you better be very careful. So if that high point occurs at the end of a graph, well, then you got a problem. That graph would have no max because of that open circle. So once you figure out that concept, it's not tricky, but there's always a few people who miss that on the test, and then they get it back and they're mad at themselves because it's not really it's not a process question. There's no derivatives to take. It's just an understanding thing. All right, those are the ones I wanted to work. Anything else you wanted to see from that section? Just there's a lot to finding a max or a min. Take the derivative, set it equal to 0 or undefined. Put those in a table of values with the endpoints and look for maxes or mins. And then be careful with the open circle business. All right. Well, if that's it, then that's it. There's no extra assignment today. Your job is to finish this assignment. 167, 1 through 45, every other odd. Tomorrow we'll start something new. It's fill in the blank notes, so that's kind of nice. It means you can focus on understanding more than focus on frantically copying things down. I will see you guys tomorrow.